Hello students, in this video we are going to discuss about different types of functions. Okay, so first of all we're gonna discuss about algebraic function. Okay, algebraic functions. What is algebraic function? Okay, suppose we have a function f(x) is equal to twice x square plus thrice x plus 1. Okay, here you see let me have another function. Suppose f of x is equal to x plus 3. Okay, so it may be f of x is equal to suppose 1 by x square plus 1. Okay, so now you see, so these are what algebraic expressions. Okay, these are algebraic expressions. Okay, and fx is equal to, so now you see, if f of x is equal to any algebraic functions, such functions, okay, then this function f is said to be algebraic function. Okay, it is called algebraic function. Okay, so this is what algebraic functions. So the graph of algebraic functions depends on the expression, this algebraic expressions. Okay, so if you have linear expressions like this x plus 3, then you will get a graph of straight line. Okay, so depending on the type of expressions here what you have taken, fx is equal to, okay, depending on that the graph varies. Okay, there is no fixed graph for algebraic expressions. Okay, so if it is quadratic, then you will get such kind of graphs like this. Okay, quadratic. Now you see, in this function f of x is equal to 1 by x square plus 1. Here it can be written as f of x is equal to x to the power minus 2 plus 1. Okay, now you see the power on this variable is negative, so that's why it is not a polynomial. This expression is not polynomial. Okay, on the other hand, these expressions are what? Polynomials. These two expressions are polynomials. Okay, and such kind of expressions are, such kind of algebraic expressions are called polynomial function. Okay, such kind of algebraic functions are known as polynomial function. Okay, so now if a function f of x, it can be written in the form of p of x, which is also a function of x, by another function of x, g of x, where gx is not equal to 0. In that case it is called rational function. This is called rational function. Okay, rational function. Okay, so hope you have understood about polynomial function, algebraic function, and rational function. Okay, so let's move on to next type of function, that is constant function. What is a constant function? Okay, now let us discuss about constant function. What is a constant function? Suppose we have a function such that f of x is equal to 3. Okay, so here you see, it doesn't matter what is the value of x you have put here, this function always give you 3. Okay, if you put x is equal to 3 here, sorry, x is equal to 0, then also you will get fx is equal to 3. For x is equal to minus 1 also, you will get fx is equal to 3 again. Okay, for x is equal to plus 1, fx is equal to again 3. Okay, so that means its result is fixed. Okay, this f of x is always going to be 3. Okay, such type of functions are called constant functions. Okay, this type of functions are called constant function. Okay, because the result is fixed. Okay, so a function f is said to be constant function if f of x is equal to c for all values of, so for all values of x belongs to r. R means real number. Okay, where c is a fixed real number. Okay, this is the definition of a constant function. Okay, so here f of x is equal to fixed real number. Okay, in that case this function is said to be a constant function. Let me show you how to draw the graph of this function. Okay, so now you see, in order to draw the graph, so here we have a Cartesian plane. This is x-axis, y-axis, and this is the origin, suppose O. Okay, so if you consider y is equal to f of x, which is equal to c is a fixed real number. Okay, suppose this length is equal to c. Suppose, now you see, it doesn't matter what is the value of x, 0, whether it is 1 or 2 or -1. Okay, here you see, the value of y is always going to be equal to c. That's why we will have a straight line which is parallel to x-axis. Okay, so this one will be the graph of a constant function. Okay, now as you can see, we can put any value of x here. Okay, we can put any real number. Okay, x is equal to any real number. That's why domain of such function is set of all real numbers, and the range is the set. Range of this function is the set containing the constant value. Okay, because here you see, doesn't matter what is the value of x, you will always get c. Okay, that's why the set of the range of this function is a set of containing c as an element. Okay, now let me show you one more example of constant function, how to draw the graph of constant function. Okay, suppose we have a constant function y is equal to, suppose, f of x, which is equal to, suppose, 3. Okay, then if you see, if you put the value of x is equal to 0, if you put x is equal to 0, then this function will give you 3. Okay, that's why y equal to 3. If you put x is equal to 1, then also you will get y is equal to 3. If you put x is equal to -1, then also you will get y is equal to 3. And if you put x is equal to -2, then also you will get 3. Okay, so let us plot those points on this Cartesian plane. Then what you will get? So first point is 0, 3. This is 0, 3. This is the value of x. It is 0, 3. 1, 2, 3. Okay, so this is what? 0, 3. This point is 0, 3. Now let us plot this point, 1, 3. Okay, this is 1, then 1, 2, 3. This point is 1, 3. Okay, next is -1, 3. So this is -1, 1, 2, again 3. This is -1, 3. Okay, this point is -1, 3. Okay, similarly, if you put -2 here, this is -2, 1, 2, 3. This point is -2, 3. Okay, now if you join these 3 points, this one and this one, then what you will get? You will get a straight line, okay, passing through these 3 points. Okay, so this is the graph of this constant function. So hope you have understood what is constant function and what is how to draw the graph of this type of functions. Okay, now let us discuss about identity function. Okay, so what is identity function? Okay, suppose we have a function f of x. Okay, a function f of x is equal to x. Okay, that means if you put x is equal to 1 here, then it gives 1. If you put x is equal to 2, then it gives 2. Suppose, again 2. Okay, if you put x is equal to 3, then it gives 3. Then this function f is said to be a identity function. Okay, identity function. So what will be the definition of this function, this type of function, identity function? That means, okay, a function f is said to be identity function if f of x is equal to x. Okay, f of x is equal to x for all x belongs to R. That means for any real number x equal to any real number. Okay, then this function f is said to be identity function. Okay, so hope you have understood. Now let me show you the graph of this function. Now let me show you how to draw the graph of this function. Okay, now you see, let us consider y is equal to f of x. Okay, as we have got y is equal to f of x is equal to, according to the definition of identity function, we have got f of x is equal to x, so y must be equal to x. If y is equal to x, then if you put x is equal to 0, then y must be 0. If you put x is equal to -1, then y must be -1. If you put +1, then it should be +1. Value of y should be +1. If the value of x is 2, then y also 2. Okay, if your value of x is -2, then y is also -2. Okay, so if you plot those points here on this graph, then what you will get, 0, 0, this is 1 point, 0, 0, then here -1, 1, this is -1, this is -1, this is the -1, 1. Okay, let me write the origin on the other side. Here is the origin. Okay, now you see, then 1, 1, this is 1, 1, this point is 1, 1, so this is 1, 1, this is 0, 0, and this is -1, -1. Okay, similarly this is 2, 2, 2, 2, and -2, -2 will be this one. Okay, this is -2, -2. Okay, then the graph of this function will be obtained by joining these points. Okay, so let me join the points, those points. Okay, I have plotted here. So this is the graph, required graph. Okay, so this is the required graph of identity function. Okay, so now here you can see, you can put here any value, any real number. That's why its domain must be, domain of this function must be R. That means set of all real numbers, and the result you are getting here is equal to the number you have put here. So that's why domain and range of this function both equal to R. That means real numbers, set of real numbers. Okay, so if you put 1, then you get 1. If you put 2, again you will get 2. That's why if df is R, then rf must be also R. So that is all about identity function. Okay, now let me tell you about reciprocal function. Okay, now let us discuss about reciprocal function. Okay, a function f is said to be reciprocal function if it is defined as f of x is equal to 1 by x. Okay, for all real value, for all real numbers, x belongs to R. Okay, other than here you see x should not be equal to 0. Okay, here x cannot be equal to 0. Okay, so now you see this function, such type of function f, if f of x is equal to 1 by x, that means if you put x is equal to 1, then you will get 1 by 1, that is equal to 1. Okay, if you put x is equal to 2 here, then you will get 1 by 2. If you put x is equal to 3, then you will get 1 by 3. Okay, such types of functions such type of function is called reciprocal function. Okay, now let me show you how to draw the graph. In order to draw the graph, let us take y is equal to fx. Okay, let us take y is equal to f of x, or you can say y is equal to f of x is equal to 1 by x, so you can write directly 1 by x. Then let me make a table here. Okay, x. So here we are going to put the values of x and here y. Okay, so let me put x is equal to 1. Okay, x is equal to 1, then y will be also 1. Let us put x is equal to -1, then y will be also -1. Let us put x is equal to 2, then y will be 1 by 2. If you put -2, then y should be -1 by 2. Okay, -1 by 2. Let us put +3, then you will get 1 by 3. If you put -3, then you will get -1 by 3, or 1 by -3, same thing. Okay, if you put +4, then you will get 1 by 4. Then if you put -4, then you will get -1 by 4. Okay, so let us plot those points on a Cartesian plane. Okay, so let me draw a Cartesian plane here. So if you plot the positive values, then on the first quadrant you will get such kind of graphs. Graphs should be like this. Okay, and if you put the negative values, those values on the Cartesian plane, then on the third quadrant, in the third quadrant, you will get this graph. Okay, like this. Okay, so this is the graph of reciprocal function. Okay, so that's how you can draw the graph of reciprocal function. Okay, so domain and range of this function, domain and range of reciprocal function, okay, is equal to r minus set containing 0. That means neither you can put 0 here nor you will get 0. Okay, so that's all. Now let us discuss about square root function. So what is a square root function? A function is said to be square root function if f of x is equal to root over x. Okay, so here you see, if it is root over x, then you cannot put negative numbers. So definitely its domain of this function will be equal to 0 to infinity. Okay, so this is square bracket, means it is closed interval on the side of 0. That means 0 is included. Okay, so this must be the domain. Okay, so now you see how to draw its graph. In order to draw its graph, let me make a table here containing values of x and y. Okay, so this is x, y. If you put x is equal to 0, then you will get y is equal to 0 here. So if you consider y is equal to f of x, if you consider y is equal to f of x, which is equal to square root of x. Okay, so if you put x is equal to 1, then y will be equal to 1. If you put x is equal to 4, then square root of 4 is 2. And if you put 9, then square root of 9 is 3. So these are the values. Let us put those values on those points on a Cartesian plane. Okay, so let me draw a Cartesian plane here. So let us plot those points here on the Cartesian plane. Then 0, 0 is this point. This is the point 0, 0. So 0, 0, and next point is 1, 1. This is the 1, 1. Okay, 1, 1, and next one is 4, 2. This is the point 4, 2. Next one is 9, 3. This is 9 comma 3. This is the point. So this is the point 9 comma 3 here. So let's join this point in order to obtain the graph. Okay, so graph should be like this. This is the graph of square root function. Okay, that's how we can draw. And remember, the range both are equal to this close interval 0 and open at infinity. Okay, so 0 to infinity including 0. Okay, domain and range both of this function are equal to the interval from 0 to infinity. Okay, so this is the domain and range. Okay, so hope you have understood this. What is square root function, how to draw its graph, what is the domain and range of this function. Okay. Let us discuss about absolute value function. Okay, absolute value function. Okay, what is an absolute value function? A function f is said to be absolute value function if f of x is equal to mod of x. Okay, so what does it mean, mod of x? Now you see, if x is equal to -2, then mod of x will be +2. If x is equal to +2, then also it will be +2. Okay, so it doesn't matter what is the value of x, whether it is positive or negative, it's always gonna give positive value. Okay, so that is the meaning of mod. Okay, so now let me show you how to draw the graph of this function. Okay, so let me have a table here. So first let me write here, first let us consider y is equal to f of x. Okay, so y must be mod of x. Now let us find corresponding values of x and y in order to draw the graph. Okay, so let me make the table here below this function. Okay, x and y. So if we put x is equal to 0, then y will be 0. Okay, if you put here x is equal to, suppose, -1, if you put -1, x equal to -1, then you will get +1. If you put -2, then you will get +2. If you put +1, then also you will get +1. If you put +2, then also you will get +2. If you put -3, then you will get +3. If you put +3, then you will get +3 again. Okay, so let us plot those points on a Cartesian plan. Okay, on a Cartesian plan. So this is our Cartesian plan. Okay, now let us plot those points on this Cartesian plan. Okay, first 0 comma 0, it must be at the origin, this point. Okay, then next one is -1 comma 0, -1 comma +1. Okay, -1 comma +1, this is the point, -1 comma +1. Next point is -2 comma +2, -2, this is +2. Okay, so here is the point, this is 0 comma 0, this is -1 comma 2, then this is, sorry, this one is -1 comma +1 here, and this is -2 comma +2. Then let us plot now +1 comma +1. Okay, so this is plus 1 and this is plus 1. Okay, then next one is 2 comma 2. Here is 2 and this is also 2. 2 comma 2, this is 2 comma 2. Then next let us plot 3 comma 3, minus 3 comma 3. This is minus 3 comma plus 3. So this is minus 3 and this is plus 3, isn't it? So here is the point. Okay, this is the point. So then 3 comma 3 must be here. So I hope you know how to plot the points. Okay, this is minus 3 comma 3 and here it is 3 comma 3. This is 2 comma 2 and this is 1 comma 1. So graph should be like this. Okay, so this is the graph of this absolute value function. So this is how we can draw the graph of absolute value function. Here you see we can put all the real numbers here. Okay, we can put all real numbers, doesn't matter what you put here, you will always get a positive value. Okay, so that's why domain should be here. Domain of this function will be real numbers, set of all real numbers. Okay, but in range you will get only positive numbers, that's why including 0. Okay, including 0. So close interval 0 to infinity. Okay, this is the range of this function. This is the domain, this is range. So hope you have understood this. So our next function is Signum function. Now we are going to discuss about Signum function. Okay, now we are going to discuss about Signum function. What is Signum function? Okay, a function f is said to be Signum function if f of x is equal to either mod of x by x. Okay, mod of x by x if x is not equal to 0. Okay, if x is not equal to 0, okay, that means either greater than 0 or less than 0. Okay, and 0, fx is equal to 0 if x is equal to 0, then this function f is said to be Signum function. Okay, now this function f of x also can be written as, or f of x is equal to 1 if x is greater than 0, 0 if x is equal to 0, or minus 1 if x is equal to, x is less than 0. Okay, now you see for x greater than 0, f of x is mod of x by x, which is equal to 1. Let me tell you how. If you put x is equal to 2, then f of 2 will be equal to mod of 2 by 2. Mod of 2 is 2, then 2 by 2 is 1. If you put x is equal to 3, that is f of 3 will be mod of 3 by 3, that's going to be again 1, because mod of 3 is 3. Now if you put negative values, suppose x less than 0, then what will happen? For those values, here you see, if you put minus 1, x is equal to minus 1, then f of minus 1 is mod of minus 1 by minus 1, and mod of minus 1 is plus 1, by minus 1 again it is minus 1, plus 1 by minus 1 is minus 1. So if you put x is equal to minus 2, then f of minus 2 will be mod of minus 2 by minus 2. Mod of minus 2 is plus 2 by minus 2. Then here 2 gone, 1. So that's going to be minus 1. Okay. So that's why here you can write for x less than 0, you can write fx is equal to minus 1. If x is equal to 0, then you can write fx is equal to 0. Okay. For x greater than 0, fx will be equal to 1. So hope you have understood this. So now let me show you how to draw the graph of this function. Okay. As you can see, for x greater than 0, for all values of x greater than 0, if you consider, let us consider y is equal to fx. Okay. And fx is 1 for all x greater than 0. It doesn't matter what is the value of x. It is 1, 2, 3 or 4. It is always value of 4. It's going to be plus 1 for all x greater than 0. Okay, that's why graph of this must be this one. Okay, this is y equal to plus 1, and it is 0 when x is equal to 0. Okay, so y will be equal to 0 when x is equal to 0. That's why this point is also included, origin. Okay, and y is equal to minus 1. Okay, this we have considered y is equal to fx, and fx is minus 1 for x less than 0. For any value which is less than 0, that means it may be minus 1 if the value of x is minus 1 or minus 2. Okay, any value less than 0. Okay, less than 0. So y is equal to minus 1. So this is the graph of minus y is equal to minus 1. This. Okay, so here it is minus 1. This is y is equal to minus 1. Okay, so that's how we can draw the graph of Signum function. So what will be its domain? Now you see, you can put all the values equal to x equal to 0, x greater than 0 and x less than 0. That means its domain must be, domain of this function must be real number, set of all real numbers, and range of this function. So doesn't matter what value you put, we can get only these three values, which are plus 1, 0 and minus 1. That's why range must contain minus 1, comma 0 and plus 1. Okay, only these three results we can get. Okay, what are the results? Plus 1 and 0 and minus 1. So that's why range is this set containing minus 1, 0 and plus 1. Okay, so hope you have understood this, what is Signum function. Next we're going to discuss about greatest integer function, also known as floor function. Okay, now let us discuss about greatest integer function. Okay, what is greatest integer function? Suppose n be any integer. Suppose n is an integer. Okay, so we have considered n is any integer. Okay, then we have a function, suppose f of x, which is equal to n minus 1 when x is greater than n minus 1 and x is less than n. Okay, when the value of x is less than n or greater than n minus 1, then f of x is given by n minus 1. Okay, n minus 1. Okay, now f of x is equal to n when the value of x is greater than equal to n, greater than n equal to n, and less than n plus 1, Okay, so then the value of fx is n. Okay, then this function f is called greatest integer function. Greatest integer function. Okay, greatest integer function, and it can be expressed as f of x as this x can be written within square bracket like this, or you can write this one as this. Okay, this is also known as floor function or step function. Okay, so this is what greatest integer function. That means suppose we have a number, suppose x is equal to, suppose we have x is equal to 0.5. We have 0.5. Now you see 0.5 is less than 1. Yes, less than 1. It is greater than 0. That means it is greater than 1 minus 1. Okay, it is greater than 1 minus 1 and less than 1. Okay, then according to the definition of this function, then greatest integer function of 0.5 must be equal to 0. Okay, it must be 0. So now you see, suppose we have x is equal to 4. X is equal to 4. Then f of 4, okay, this greatest integer function f of 4 will be equal to 4, because according to this definition you can see f of x is equal to n when x is greater than is equal to n. Okay, or less than n plus 1. Here 4 is greater than equal to 4 and less than 5. That's why according to this definition, so f of 4 must be equal to 4. Okay, less than 5 means less than 4 plus 1, isn't it? So suppose we have to find f of 9.1. okay, then by the definition of greatest integer function, so what will be this value? What will be the value of this 9.1 if x is equal to 9.1? You see 9.1. Now you see 9.1 is greater than 10 minus 1 and less than 10. Okay, greater than 10 minus 1, that is 9, and less than 10. Okay, then you see according to this definition of this function, its value must be equal to n minus 1, that is equal to 9. Okay, that is equal to 9. So that is what greatest integer function. Okay, that means it depends on the value. Suppose f of x is a if f is a greatest integer function, if f is a greatest integer function, so here you see if x is not an integer, suppose 9 point something, 9.1 or 9.2, okay, or 9.3, in that case its value will be 9. F of 9.1, 9.2, this one. Okay, now you see if x is equal to an integer, that is 9, then also it will be 9. Okay, so hope you have understood what is the greatest integer function. Okay, that means we have to take the greatest integer which is very close to this number we have taken here as a value of x, or equal to that. Okay, so if it is not an integer, so that value cannot be equal to this one. If it is an integer, then itself is the result. Okay, now let me clean this part first. Okay, now let me tell you what is the domain and range of this function. Okay, so now you see here domain of this function will be real number. Okay, that will be real number, set of all real numbers. Okay, because here you can see we can put any value of x here. Okay, any real number, we can put any real number, but we will always get an integer. Okay, we will always get an integer. So that's why range will be r of range of the function f will be I, that is integer. Okay, integers. It may be negative also. Okay, suppose we have a negative value of x. Suppose x is equal to suppose we have minus 2.5. Okay, minus 2.5. Then here you see minus 2.5. Then here you see, if you observe the number line, okay, so let me draw it again. This is suppose 0, this is minus 1, this is minus 2, and this is minus 3. So minus 2.5 must be lying between some here, it must be here. Okay, so in case of greatest integer function, what you have taken the value of x. Okay, so if it is an integer, then result will be itself the value of x. Okay, if it is not an integer, it is a fraction like this 2.5, it is negative. Okay, then you have to take the greatest integer left to it. Okay, greatest integer left to it. Suppose if you have a positive value, suppose this is 0, this is 1. Okay, so you have 1.5. Suppose you have x is equal to 1.5. Then greatest integer function, by the definition of greatest integer function, then you will get f of 1.5 will be equal to 0. You have to take the integer on the left of this value on the number line, that is 0. That's very simple. Okay, so here f of minus 2.5 must be equal to, in this case, if x is equal to minus 2.5, then by the definition of greatest integer function, it must be equal to minus 3. Okay, suppose if x is equal to plus 2.5, suppose x is equal to only 2.5, then if let me draw the number line here again. This is 0, this is 0, this is 1, suppose this is 2, and this is 3. So 2.5 is here, this is 2.5. Then you have to take the number on the left side, which is the greatest integer on the left side of this number. Okay, so that is all about greatest integer function. So that's why here range is the set of all integers. Okay, and here domain is the set of all real numbers. Okay, now let me show you how to draw the graph of greatest integer function. If f of x is this. Okay, graph of greatest integer function. So let us consider y is equal to f of x, which is within square bracket x, which represents greatest integer function. Okay, now you see, let me write the values of x here, and on the other side let us write the values of y here. Okay, now if the values of x is suppose greater than equal to 0 and less than 1, then by the definition of greatest integer function, this y must be equal to 0. Okay, so greater than equal to 0, less than 1 means it may be 0, 0.1, 0.2. From the number line, real number line, you see this is 0, this is 1 suppose, then here it is 0.1, suppose 0.2, 0.3, 0.4, 0.5, like this. So here you see, suppose we have a number here 0.3 or something, suppose 0.3, then so the greatest integer on the left of this number is 0, that's why its value is 0. Okay, similarly if x is greater than equal to 1 and less than 2, if it is less than 2, Okay, then y will be equal to 1. Okay, then if x is greater than equal to 2, less than 3, then y going to be equal to 2. Okay, similarly, if x is greater than equal to minus 1, less than 0, then y must be minus 1. Okay, similarly, x is suppose greater than equal to minus 2 and less than minus 1, then y is minus 2. Okay, so now let me show you how to draw the graph here. Okay, so here is the Cartesian plane. Now let me plot these points. Okay, so for x is equal to x greater than equal to 0, that means 0 is included here, and less than 1. So here we have to make a circle here. So when x is equal to 0 and less than 1, okay, then y is equal to 0. Okay, so here is the point. So you see, first let me plot one more point. Okay, again then I will tell you. So if x is greater than equal to 1, okay, if x is greater than equal to 1 less than 2, okay, greater than equal to 1 less than 2, then y is equal to 1. Okay, in this region, that means this region. Okay, if x is greater than equal to 1, so 1 on x coordinate 1 should be included, 2 should not be, 2 is not included here. Okay, so here this darkened circle means it is included, and this circle which is not darkened at the center, or its inner region, that represents it is not included. The point where it is drawn is not included. So here you see, for this point x is greater than is equal to 1, so 1 is included, and less than 2, so along x-axis 2 is not included. So y is equal to 1, so along y-axis it is 1. Okay, this length is 1, isn't it? So hope you have understood this. Then next point is x is greater than equal to 2. Now here you see x is greater than equal to 2 and less than 3, for that y is equal to 2, so it must be here. Now 2 is included because x is greater than equal to 2 and less than 3, this 3 is not included. And for this region, for this interval x greater than equal to 2 less than 3, the value of y is 2. Okay, so for this interval value of y is 2. Okay, so that's how we can draw. Okay, similarly, when x is greater than equal to minus 1 and less than 0, okay, less than 0, greater than equal to minus 1, in that case y is minus 1. So if y value is minus 1, then move downward, and minus 1 is included, the interval which represent x greater than equal to 0, sorry, greater than equal to 1 less than 0. Okay, less than 0. So here at this point x is 0. Okay, x is 0, y is minus 1. Okay, so here you see 0 is not included, and minus 1 is included here in this interval. Minus 1 is included, that means x is greater than equal to 1 minus 1, that means minus 1 is included. So here you see you have to make this circle dark, okay, in order to represent this. Okay, so for this interval y value is minus 1. Okay, So hope you have understood this. So now similarly next interval can be drawn as here -2 x is equal to greater than equal to -2 and less than -1. Here -1 is not included, -2 is included, so make it dark. Okay, and for this interval value of y is 2. Okay, sorry, -2. This is the graph for the floor function or step function, or you can say greatest integer function. Okay, so that's how you have to draw this graph. So let us discuss about smallest integer function. Suppose we have an integer n, that is suppose integer, okay, belongs to I. So now you see a function f is said to be smallest integer function also known as ceiling function. Okay, this is also known as ceiling function. Okay, if f of x is equal to n, if x is greater than n minus 1 and less than equal to n, and it will be n plus 1 if x is greater than n and less than n plus 1. Okay, so let me explain in details. Suppose we have a real number, this is 0, here it is 1, 2, 3. Okay, suppose we have a number between 1 and 2. Suppose we have a number between 1 and 2, suppose 1.3. Now 1.3 is greater than 1 and less than 2. Okay, that means you can say that 1.3 is greater than 2 minus 1 and less than 2. Then according to the definition, it must be equal to 2. According to this definition here, you see, it must be equal to 2. So ceiling function or smallest integer function of 1.3 must be equal to 2. That means if it is a fraction, then you have to take the integer, smallest integer, on the right hand side. But in case of greatest integer function, what we did, we had to take integer on left side, greatest integer on left side. But for this function, smallest integer function, we need to take the smallest integer on the right hand side of the number which is taken here. Okay, suppose we have another number, suppose this is suppose 0, this is minus 1, this is minus 2. So we have suppose minus 1.5. Okay, then ceiling function of minus 1.5 will be what? Here you see it is minus 1.5 is less than minus 1 and greater than minus 2. So that's why it must be equal to minus 1. Okay, so you have to take the greatest integer on smallest integer on the left hand side. Okay, because it is an smallest integer function. Now let me show you how to draw the graph of smallest integer function. Okay, or ceiling function. Okay, so in order to draw the graph, let us consider f of x, y is equal to f of x. Y is equal to f of x, that is ceiling function of x. Okay, then let us take values of x and y. Okay, if we take here x is, suppose, let me use another color, x is suppose greater than 0 and less than equal to 1. Okay, then y must be equal to 1. If x is greater than 1 less than equal to 2, then y must be 2 according to the definition of smallest integer function. Then if x is greater than 2 less than equal to 3, then y must be equal to 3. Now let us take x is suppose greater than minus 1 less than equal to 0, then y must be 0. If x is greater than minus 2 and less than equal to suppose minus 1, then y must be minus 1. Then if it is x is greater than minus 3 and less than equal to suppose minus 2, then y must be minus 2. Okay, so now let me draw the Cartesian plane here. So here is the Cartesian plane. Let us draw the graph of this smallest integer function. Here you see this one, x is greater than 0 less than equal to 1. That means 0 is not included, 1 is included in this interval. So and corresponding value of y is equal to 1. So we have to move one division upward, and as along x-axis, along this direction, along x-axis, as you can see 1 is included. We have to make a circle and it should be darkened. It should be darkened like this, and here you see 0 is not included here. Okay, this interval, for this interval value of y is equal to 1. Okay, so that's how we have to draw this one. Here you see 1 is not included, 2 is included, and value of y is 2. So here is the value of y, 2. Here this point 2 is included, that's why we have to make a dix. That means if you draw a circle, if you make it dark like this, then it is called dix, isn't it? So that means where you make this circle and if it is darkened, then this point is included. Okay, so here 1 is not included, this 1 is not included. So for this, in this interval here you see 1 is not included, 2 is included, and value of y is equal to 2. Okay, similarly we will get the graph like this. Okay, and towards the negative side also, here you see minus here you see minus 1 is not included, 0 is included in this case, while y is equal to 0. So it must be on x-axis, this interval must be on x-axis. Then next one should be here. So that's how you can draw the graph of smallest integer function. So hope you have understood this, how to draw the smallest integer function, graph of smallest integer function. So here this is included. Okay, so in this chapter we are not going to discuss about trigonometric function. Okay, so because the third chapter of NCERT textbook of mathematics is based on trigonometric function. Okay, name of the chapter, third chapter, is trigonometric function. So we will discuss about that trigonometric function in that chapter. Okay, so in the next video I'm going to show you how to solve the problems of exercise 2.3 of NCERT textbook of mathematics class 11. Okay,